Hello everyone, and welcome to the 41st Objective-C tutorial. In this tutorial, I'm going to be covering how we can use NSSort descriptors in Objective-C. So in the previous tutorial, I showed you how we could use NSPredicate to filter out results in an array, in our example anyway. And basically what this allows you to do is simply search for some kind of term, and then everything that matches you keep, and everything that doesn't match the term you're searching for you filter out, and then whatever you're left with is, like I said, just whatever you're looking for. And this is just, how every search basically ever worked. You search for a term, and whatever actually matches that term is left. And that's what NSPredicate allows you to do, and that's what we learned in the previous tutorial. But if you want to be able to sort your array, so let's say we want to sort an array by age, then this is different. We don't want to use NSPredicate, we want to sort it using an NSSortDescriptor. And as the name would kind of suggest, it is basically used to sort stuff. So before I get into this tutorial, in case you're just jumping into lesson 41, you might be wondering what this person object is. And we created the same person object in lesson 40, but I'm just going to quickly run through this so that if you're watching this tutorial now and you didn't watch the previous one, then you'll know what we're doing. But if you did do lesson 40, you can just copy over the person class that we created in that tutorial to this one. But anyway, what you're going to want to do for this tutorial is just go ahead and create a new Objective-C class, call it person, and for the person you're going to give them a name property and an age property, and then you can say init with name, and from there we can just go to our person.n, and we're going to simply initialize the name and the age in there, and then we're going to create a description method as well, simply printing out the name and the age of the person. And this just allows you to, whenever you go to print the object out, the description method is what gets displayed basically. So some people I think were wondering in the last tutorial what the description method did, and that's from the very early Objective-C tutorials. Again, the description method is just used to print whenever you go to print your object. So you nslog whatever the person object, the description method is what gets displayed when you nslog that object. Alright, so with that anyway, that's all you really have to have for the person object, and once you've done that, make sure you import it like that into your main.m. So with that, we just go ahead and create a bunch of person objects. You don't have to copy what I have, but if you want, feel free to. Alright, so now that you have those person objects, once you've completed that, you've put them all in an NS array, now we want to figure out how we can sort this array of people. So as we can see, they got a bunch of different names, some different ages, some are the same, and we're just going to see what we can do with this. So to create a sort descriptor, we obviously have to, well, create one. So we're going to say NSSortDescriptor, and we'll just call it sorter, and we'll say NSSortDescriptor alloc, and we'll use, I'm just going to collapse this side view so I have a little bit of more room. We're going to use the init with key ascending method. And so all I have to do for this is pretty self-explanatory. Init with key is just asking for the key I'm going to be comparing or sorting. So in these person objects that I'm going to sort through, I want to look at their name key or name property, and I just want to compare those. So I'm just going to type in name, and that's the key value that I'm going to be comparing when I'm going to sort through all these objects. So that's pretty self-explanatory. We did that in the last tutorial, and again I said that I wanted to compare the ages, so I'm going to change the key to age, and that just means I'm going to look at the age key and I'm going to compare those. Alright, so now with this ascending little thing at the end, this always confuses people what ascending and descending means, maybe not just in Objective-C but in general. I'm not really sure, but it is kind of confusing, so I'm going to explain it. The ascending in Objective-C, we have a few sort of different things, but in general, if you're going to compare different objects and you want them to display ascendingly, then you are starting from the earliest value or the first value, and then you're working your way to the last possible value that's available. So if you want to sort a list of things ascendingly, so in our example here we're going to sort ages, and if I want to say ascending yes, That means I want to sort them ascendingly. That means I'm going to start with the earliest age and then sort them all the way down to the latest or the oldest age, right? So that's going to start with the smallest number and work its way to the largest number. That's what ascending means in Objective-C. Now, if I want to apply this to my names, if I want to sort the names ascendingly, that would mean that I'm going to start with the earliest letter, the first letter, and sort all the way down to the last letter. Again, that's what ascending means in Objective-C. Now, if you're going to sort them descendingly, that means that you're going to start with the furthest value. That's going to be displayed first, and then you're going to sort them all the way down to the earliest value, or the first value. So if I was to say sort this ascending no, that would mean that I'm going to start with the oldest age, which would be Yoda, and then I would start working my way back down. So I'd start with 9, or then I go to 19, 18, and 16, etc. Same goes for the strings. Basically, if I say ascend no, that means they're descending, and I'm starting with the latest value, or the furthest letter, and then I'm working my way back. So Z would be the first thing that would be printed out, and I'd work all the way back to, the A characters. So for this, I'm just going to start with ascending yes, and again, that just means that I'm going to start with the earliest age, go to the latest age. But anyway, that's worth explaining, I think, because it's kind of hard for some people to grasp. Alright, so from here, once I have my sort descriptor, I have to put my sort descriptor into an NS array. And this is usually just an array of sort descriptors, like so. And I can just say @, objects, and put in my sorter like that. Alright, so I'll explain why we have to put into an NS array in just a bit, but just go ahead and put your sort descriptor into an NS array. Alright, so now what we want to do is create a new NS array that's going to contain all the sorted values. So this is going to be my sorted array. And I'm going to just create this new array from my original people array. So I'm going to say people, and I'm going to create a sorted array using descriptors. That's the method that I use. And as you can see, this passes in an NS array value of descriptors. So I'm just going to put in my sort descriptors like that. So now what that's going to do is it's going to sort through the people array using the given sort descriptors that I pass in, and it will return the sorted array with whatever I specified in this sorter object right here. So just to clarify why we put it in an NS array, consider consider this example here where we're sorting through our ages. And you see that we have age 18, age 18, and age 18. So how do I know what I'm going to sort after that value, right? Because if they all have the same age of 18, I don't really have anything else to sort them by. And I could, if I wanted to, add another sort descriptor to this, maybe sorting them by alphabetical name, right? So I could create another sort descriptor after this one, and I could add that to the array. And that means that when this goes to sort through objects, it's going to look at the first sort descriptor in the array. It's first going to sort the list by that sort descriptor. And then if there's anything that's the same, it's going to go to the second sort descriptor and sort it by that. So if I put in another one comparing the names, then it would sort any of these ages that are the same, and then it would sort them alphabetically. So that's the reason we put it in an array, just so that if there's anything that comes out to be the same value, we can have something else to sort them by. But in this example, we just want to use one sort descriptor. Alright, so now that we have that, the last thing we want to do is, of course, print these values out. So I'm just going to print out my sorted array, like so. And moment of truth, we'll go ahead and run this here. And as you can see, we get all these values starting from the earliest age of 16 and working all the way down to Yoda's 900. And I don't actually know if Yoda's 900, but according to Wikipedia, when I looked, he died when he was 900. Somebody mentioned that in the last tutorial, but I just thought it was, I don't know, if you think he's 800 years old, you can put that. But anyway, don't judge my skills of Star Wars. All right. Anyway, with that, we have that's all I want to show you for comparing the age. Now, if I want to compare, let's say I want to compare them by name length. So I could use the key name.length That just means that I'm going to look at the name key, which is this name property, and then I'm going to also ask the names for their length, which is an NSString method, which just returns an integer defining the length of each string. So if I want to sort this ascendingly, this works the same way. Again, the smallest value, so the earliest number, is the first thing that's displayed, and then the furthest, or the largest number, will be at the end. So I can go ahead and run this here. And as you can see, my names are now sorted by their length. So Z obviously is first because he only has one letter. And then as you can see, we have 4 and then 5 like that. So that's using a different thing for key. We're just throwing in the dot and we're adding on to our key that we're looking for here. Alright, so now let's say I just want to compare the names. So, this is something that we do all the time if we're comparing names of people. We want to compare them by their name, right? So let's go ahead and run this and see what happens. So as you can see, it actually does a really good job of just sorting through names. It goes through them alphabetically and then it displays them in order. So that's pretty cool. Now the only issue with this is, let's say we have some kind of form that people enter all these names into. Somebody's dumb and enters their name without a capital letter. And so let's just change Matt to lowercase m. And I go to run this. And now we can see that our list, oh great, it's all out of order because Matt didn't put his capital letter in for his name. So how can we fix this? That we just want to sort the letters in, not depending on if it's capital or not. And in case you're wondering why the M comes after all the others, is because when you sort strings in Objective-C, basically if it's a capital letter, it'll sort it from A to Z like that. But then as soon as you go to lowercase letters afterwards, it then will come after all the capital letters. So it goes from capital letters A to Z and then lowercase letters A to Z. That's how strings are sorted in Objective-C. That's why the M comes after all these capital letters here. Alright, but what if we want to fix this? Well, we can fix it with another method in the NSSortDescriptor class called Init with key ascending selector. Now this section here allows us to sort the strings with a given selector, and a selector is just basically a method name in Objective-C. So we can use @selector like so. And let's say I'm just going to show you basically what the sort descriptor does without this selector parameter. So what it's actually using to compare these strings is just the compare method name like that. And so I'm sorry this is kind of jumping across lines here, but anyway, this selector is simply the compare selector. Just compares two string values, and it doesn't it pays attention to the case of the letter. So if there's a lowercase, it's just going to do the same thing that just happened when we printed it out. So if I go to run this, you'll just see that it behaves the exact same way as before. The point of me just telling you this is that without this selector parameter, that's what this is doing when it compares the strings. It's using this compare selector basically to compare all the string values. Now, like I said though, if I want to compare this without having this issue of lowercase letters coming after the capital letters, I can use a case insensitive compare, which is another method in the NSString class that can compare strings. So obviously, as the name might suggest, it is case insensitive, which means it doesn't care about the case. It's just going to sort them by how they would normally be if I looked at a bunch of letters and I'm ignoring the case. So I go ahead and run this, and as you can see, now Matt is back being on this middle playing ground here, because he is actually the M comes between a J and an S, and using the case insensitive compare, we're allowed to have that happen. Now the last thing I want to show you is something that's a little more confusing, just because I haven't really covered it much, but it's to do with blocks in the sort descriptor. And I figured I'll just try to cover it anyway to the best of my ability, but if you don't understand, I'm going to do another tutorial on using blocks in Objective-C. But anyway, we can use there's one more method called Init with key ascending comparator. And as you can see, that it has this weird sort of syntax, but this is block syntax, and I've already covered 2 tutorials on block syntax, but this is probably still going to be a little out of the league of what I've covered. But anyway, if you want to use this method allows you to compare two objects any way you want. You can just return how you want to compare them. You can return if the one object comes before the other or not. So it's pretty neat. You can basically compare whatever object you want. You can just tell it that one object comes before the other. So how does this work? Well, if I create this method, you'll see that I'm hovering over this sort of little token right now. If I select the whole thing and hit return, then it automatically fills in this block for us like that. So what does this mean? Well, the little caret sign right there indicates that we're using a block. And I'm going to simplify this as much as I can. Basically, we're using this block, and this is a NSComparator block. And this is defined in Apple's Foundation types list, I think. And basically, what it basically does is just NSComparator is a block. That's all it really is. So what this block does is it's a block of code that can be run whenever we go to compare results. And the return type of this block is NSComparisonResult. And what's compared is these two objects. So what I'm doing is basically this will ask me, here's two objects that we're going to compare. Tell me whether object 1 comes before object 2. That's really all we're doing in this block. So I'm really simplifying this, and this might not make too much sense for if you don't understand blocks in method names, but I promise I'll cover that more in detail in another Objective-C tutorial. But let's say I want to compare, let's do the example of comparing the length of their names. So I can say init with key name, and that means that the objects will simply be the names of every person that I'm comparing. So if, for example, I want to say that we're going to compare the object's name lengths, right? So we're going to say object 1, and we want to compare its length. And if its length is less than object 2's length, so basically that means that object 1 has a smaller name than object 2. If object 1's name has a smaller size than object 2, then I want it to come before object 2. So all I have to return is some value of NSComparisonResult. And if you want to look at these values, you can hit your Option key and hover over NSComparisonResult, and you'll see that it shows you the three different values that you can use. We're going to use the NS-ordered ascending and NS-ordered descending values. And these are just integers, basically. So what this does is I can say, okay, if object 1's length is less than object 2's length, then I want to simply say that object 1 comes before object 2. So I can say return NS-ordered ascending. Like I said, ascending means it comes before that value, right? If I say NS-ordered ascending, that means that the value that I'm comparing comes before the later values. So that's what I'm saying when I say NS-ordered ascending. That means object 1's value is going to come before object 2. Now obviously, if this is false, right, that means object 2's length is now actually smaller than object 1's length, which means that I actually want to put object 2 ahead of object 1. And to do this, I can say, well, I want to put object 2 ahead of you, so I'll say NS-ordered descending. And that just means that object 2 will now come ahead of object 1. So if I go ahead and run this, you can see that our results are sorted by the length of the name again. So Z comes first, and then we have the 4s and the 5s that come as well. So I'll try to explain this one more time. Again, this comparator is simply a block, and blocks again are just, they allow you to put a block of code into these methods, and it's kind of neat. You can pass along a block of code. And what this means is when it goes to compare all these results, it's going to give you the object 1 and object 2, and you're just telling it whether you want object 1 to come before object 2. And so if I say that object 1's length is less than object 2, I want it to come before object 2. And I can specify that by saying that the result is NS-ordered ascending. That means that the first object is going to come before object 2. If this is false, that means that object 2's length, again, is less than object 1's length, and that means I want object 2 to come before object 1, so I'll return NS-ordered descending. And that is my brief description, anyway, of how this comparator block works in NSSort descriptors. So anyway, if you have any questions on that, feel free to leave them in the comments below. I know I haven't covered that, but I will cover blocks in Objective-C methods in a later tutorial. And I hope, though, that you just get the grand idea of how you can use that comparator block to compare two objects. Anyway, like I said, leave your questions in the comments below. Please subscribe to the channel, and I will see you in an upcoming tutorial.